In this video, we are going to learn how to use the double angle formulas. These formulas also allow us to find exact values for trig ratios, and we will also use them when proving trig identities and solving equations. So a double angle has the format sine 2 theta, cos 2 theta, and tan 2 theta. To develop the formula, we can rewrite sine 2 theta as a compound angle, which would be theta plus theta. And using the compound angle formula, and letting theta be A and also theta be B, this would give us sine theta cos theta plus cos theta sine theta. Those are the same terms, so this becomes 2 sine theta cos theta. You could similarly prove cos 2 theta and tan 2 theta using the compound angle formulas for cos theta plus theta and tan theta plus theta. So we have the double angle formulas for sine 2 theta and tan 2 theta. And cos 2 theta has 3 different versions because the formula cos 2 theta minus cos theta squared minus sine theta squared can be rearranged using the Pythagorean identity. Remember, the Pythagorean identity is that sine squared plus cos squared is equal to 1. And we can isolate for cos squared, that's 1 minus sine squared. Or we can isolate for sine squared, which would be 1 minus cos squared. So I'll show you how this works. So let's rearrange cos squared minus sine squared to get 1 minus 2 sine squared. So cos squared minus sine squared. So we want just sine, so I'm going to replace the cos with 1 minus sine squared theta minus sine squared theta, and that is 1 minus 2 sine squared theta. And for the other version, cos squared minus sine squared, if I just want it in terms of cos, I'm going to replace the sine. I get cos squared theta, and careful, I'm subtracting here, so minus 1, and then minus the negative, so plus cos squared theta. You get 2 cos squared theta minus 1. And so this is how the other formulas come about. So again, you'll be given these 5 formulas, and you need to be practicing now to become familiar with them and how to use them. So the first question here is asking us to simplify and then find an exact value. So at the moment, we don't know how to find the sine of pi over 8 or pi over 12, 5 pi over 12 or pi over 12. And this looks fairly complicated to be using a compound angle formula on this part. So let's see, can we rewrite it as a double angle? And yes, because pi over 8 is repeated twice, so that is counting as theta. And so this equals 2, we already have the 2 outside, so this equals 2 sine theta cos theta is sine of 2 times theta, so 2 times pi over 8. So this is the sine of pi over 4, which is 1 over root 2, or root 2 over 2. This 1 minus 2 sine squared theta is the formula for cos 2 theta. So what we have is cos 2 times 5 pi over 12. So this makes cos 2, so 2 over 12, that will make the 6, so 5 pi over 6. This is in quad 2, so it'll be the negative of the cos of pi over 6, which is negative root 3 over 2. This is the tan 2 theta formula. So it equals tan of 2 times pi over 12, which is tan of pi over 6, which using the special triangle is 1 over root 3, or rationalized is root 3 over 3. In the second question, we'll just be simplifying. There will be no exact value to find. This doesn't look like the formula right now, but there is a common factor of 5. We get then 2 cos squared x minus 1. And then 2 cos squared x minus 1, that is cos 2x. Great, so this is looking nice and simplified. Here, note that the repeated angle is actually a double angle already. It's 2x. And so this will equal the cos of 2 times theta. So here it's 2 times 2x. So this is the cos of 4x. Okay, this is a similar question that we were given in the first lesson. So we're told that cos theta, we're given its ratio, but we don't know which quadrant theta is in. It could be in any of the 4 quadrants. And we want to find the exact values of cos 2 theta and sine 2 theta. Without using a calculator, I mean for the important stuff. So no actually finding the angle. So we want to find cos 2 theta. And the info we have right now is cos theta. So why don't we use the formula with cos theta, which is 2 cos theta squared minus 1. Okay, so just remember that we write cos squared theta to mean cos theta all squared. So when I'm going to plug in for cos theta, I'm going to plug in negative 2/3 and then square it. So then we'll have 4 over 9, 2 times 4 over 9 minus 1. So 8 over 9, and 1 is 9 over 9. So minus 1 over 9. So cos 2 theta is minus 1 over 9. Now to find sine 2 theta, this is 2 sine theta cos theta. Okay, and now we don't have sine theta. We're going to have to do some work to figure out what that is. So let's go back and draw this angle. Cos will be negative in quad 2 or in quad 3. So we'll have theta 1 and theta 2 option. To turn this into our triangles for SOHCAHTOA, we've got the cos of negative 2 along the x. 3 is your hypotenuse. And let's do a little Pythagorean theorem. And this will be 3 squared minus 2 squared, which is the root of 5. So up here, if the angle's in quad 2, that side is root 5, like the y value. But if our angle's in quad 3, that side is the negative of root 5. So sine theta 1 is positive root 5 over 3, whereas sine theta 2 is the negative root 5 over 3. So we're going to have 2 answers for this. An answer if the angle's in quad 2, and an answer if the angle's in quad 3. So in quad 2, sine 2 theta will be 2 times root 5 over 3 times cos theta, which is negative 2/3. This makes negative 4 root 5 over 3. 9. 3 times 3? 9. There's a excuse. Okay, in quad 3, sine 2 theta will be 2 times negative root 5 over 3. Cos is negative 2/3. So this makes positive 4 root 5 over 9. So without more information, the exact value of cos 2 theta is negative 1 over 9. And the exact value of sine 2 theta is either negative 4 root 5 over 9 or 4 root 5 over 9. So we have compound angle and double angle formulas. Like, what else can we do? So let's develop a formula for sine x over 2. This is a half angle formula. Yay. So what we're going to do is we want a formula for sine x over 2. So a good formula, so like of all our options, this would be hard to isolate. Here, this is the only part of a formula that has only sine in it. All the other sides have either sine and cos or just cos. So let's start with that formula. We're going to start with cos 2 theta, 1 minus 2 sine squared theta. So remember, we picked it since we want a formula with sine. Okay, and then we want this formula not with sine of theta, but the sine of x over 2. So let's fill in x over 2. Okay, because what we're finding, we want the formula is of, with the angle as x over 2. This is what we want. So cleaning that up just slightly on the left is just cos x. Okay, and then now let's start isolating for sine x. So I'll bring that to the left, 2 sine squared, 2 sine of x over 2 squared is 1 minus cos x. Let's divide both sides by 2. Okay, and then let's take the positive or negative root of both sides. Okay, and so there isn't actually any way we can clean this up. We can't take the root of 2 terms. We can't take the root of 2. But what we did is we isolated the sine of x over 2. And then note what this also means is the sine of x over 2 or the sine of half x. And there are 2 answers for this, the positive and negative root of 1 minus cos x over 2. So how can we use this? So for example, the sine of pi over 8 is the sine of a half of pi over 4. Pi over 4 is an angle that we know how to do something with. So this will equal the positive or negative root of 1 minus cos of pi over 4. So I'm just subbing in up here over 2. And the cos of pi over 4 is root 2 over 2. Goodness, over 2. You know what? Instead of dividing by 2, let's multiply by a half. And save fractions and fractions under the root. So we have plus or minus, and then we have, let's get this in a common denominator. So we have 2 minus root 2 over 2 times 1 over 2. So now we get 2 minus root 2 over 4. Oops. But you can take the root of the denominator, however not the numerator, and you would get plus or minus root of 2 minus the root of 2 all over 4. So you honestly can check the sine of pi over 8. We'll have these 2 possibilities. However, pi over 8 is in quad 1. So the sine of pi over 8 will be the root of 2 minus root 2 over 2. There. So that is the double angle formulas, and then look what else we could do. We got a half angle formula as well. So good luck practicing this.